Hey guys, welcome back to our channel Logic to Code. So in this video I'll be talking about Subarray Sum Equals K problem. So in this problem you have given an array and a number k, and you need to find the number of contiguous subarray of this array whose sum is equals to k, right? So the naive approach for this problem is to use two for loop and then find all the subarray whose sum is equals to k, right? But we'll try optimizing this solution. So the approach that I'll be using here is the prefix sum. So now let's consider how we are going to evaluate this contiguous subarray using prefix sum, right? So let's say this is the representation of our array. Let's say this is a variable r. So this r can vary, right? So this is the right and this is the start. So for a given r, let's say I compute the prefix sum from, this is the, let's say, 0th index. So let me write it here 0, right? So let's say this is the 0 and these dots are some indices in between, and this is the right index. Let's say star, I'll tell you later what is star is here, right? So you compute the sum from 0 to r, and let's say you call this sum as, let's say, prefix, right? So this prefix is from sum 0 to r, right? So if you know this prefix sum, then how it will help us to compute the subarray which are from 0 to r whose sum is k, right? So now what I'll do is that I'll find all the subarray whose sum, all the subarray, keep your attention here that I'm telling you that all the subarray whose sum is from 0 to some index lying between from 0 to r minus 1, right? Whose sum is prefix minus k. So I'm telling again, so this prefix is the sum from 0 to r, sum of 0 to r. Now I'm interested in finding, so let me write here, now I'm interested in finding the sum from 0 to r minus 1, right? 0 to r minus 1. Finding the sum from 0 to r minus 1, so whose sum is prefix minus k. So essentially I'm interested in finding the number of subarray starting from 0 to some index between 0 and r minus 1 whose sum is prefix minus k, right? And with these two information I am easily able to compute the number of subarray between 0 to r whose sum is equals to k. So how? Let's say from 0 to r the sum is prefix, right? And let's say there are two subarrays starting from 0 and ending index can be anywhere, right? Whose sum is prefix minus k. Let's say this is the first subarray from 0 to star whose sum is prefix minus k, right? So how we can compute the number of subarray whose sum is k? So we know the sum from here to here is what? Prefix, and sum from here to here is prefix minus k. So what would be the sum from here to here? So that would be essentially what? Prefix minus k, right? Which is essentially k. So this is the, let's say this is the first subarray, and let's say there is one more subarray from here to here, right? Here to here. So from here to here sum is prefix minus k, and from here to here sum is prefix. So we'll have a subarray from here to here whose sum would be k, right? So the problem boils down to find the number of subarray whose sum is prefix minus k from 0 to r minus 1, right? If let's say the number is x, then the number of subarray would be what? X only, right? So we'll take all the subarray from subarray and we'll just minus the sum from this 0 to r minus 0 to this particular index, right? So even if this is not clear to you, let me write the code, and with the code I'll be explaining in more detail. So what I'll do is that since I made a variable r, so r can be anything. So let me just first make a variable count in which I'll be storing all the subarray whose sum is k, right? So and the variable r can go from 0 to nums minus 1, right? So let me run a loop for that. So nums of size, right, I plus plus. So this is the, let me write here r, not I. So this is this r variable, right? So after varying r, we need to find the sum from 0 to r, right? So for that I'll make another variable. So let's say I'm making prefix equals to 0. So here I'll do is that prefix plus equals to nums of r, right? So what was the next step? Now I need to find the number of subarrays whose sum is prefix minus k from 0 to r minus 1, right? So how we'll do that? So for finding, since we are interested in finding the number of subarray, right, which essentially means the count of subarray whose sum is prefix minus k. So for that we'll be using a map, or we can use unordered map as well. So let me write an unordered map. So this unordered map will store, this is the sum and this is the count. So this sum, so once we are going to find in this unordered map, we'll be interested in finding prefix minus k. So what is the number of sum prefix minus k from 0 to r minus 1, right? So initially we don't have anything in the unordered map. So here I'll come and check. So if our unordered map contains this sum prefix minus k, if this is the case, then I'll check what is the count of that. So if this exists, then we'll just add the count in this our global count, right? So the number of subarray from 0 to r minus 1 whose sum is prefix minus k, that will be adding in the variable count, right? And after that, just we come out of this, we just update this newly formed prefix sum in our unordered map. So that I'll just update here, right? So why I'm updating after this? Because so as you can see that once we are 0 to r, we are interested in finding the number of subarray from 0 to r minus 1, right? So that's why I'm updating at the last. So in the next iteration, we'll be automatically taking from 0 to r minus 1, right? So that's just the code. So at the end, just I'll return count, right? But one thing that you can observe is that, let's say at the first time, once you find a sum, let's say r, then for that we have to have a 0 in the map. So what I'll do is that I'll just make a 0 in this map, right? So you can better understand with this example. So let's say we have this array -1 3 0 2 2 0 2 and k equals to 2, right? So you just insert 0 in your map. So initially prefix would be what? So prefix would be -1 because the first element is -1. So now I'm interested in finding prefix minus k, which is -1 -2 -3. So each um of -3 exists? Answer is no. So we don't update anything in our result. And now I'm inserting unordered of prefix in our unordered map, right? So this becomes of -1 equals to 1, right? In the second iteration, we'll just update our prefix. So prefix will be 3 minus 1, which is 2. Now we'll check whether prefix minus k exists in our map. So prefix minus k is what? of 2 minus 2, which is 0, right? So that's why I inserted of 0, right? So of 0 is because, let's say this is the first array, right? So from 0 to r, if you find 0 to r, if you find a contiguous sub array whose sum is k, then in that case we'll be using this of 0, right? So that's why I'm inserting of 0 equals to 1, right? So in this case you can see that the prefix is 2 and of 0 exists and its count is 1, so that's why result becomes 1. And then we update this prefix in our unordered map, and after that we'll just go and update our prefix, which prefix becomes 2 plus 2 4. Then we'll just update result equals to of 2, and of 2 exists, so result becomes 2. Now again we update prefix 4, then similarly, and at the end we can see that the result comes 4, right? So I think you understood the code and logic. So even if you don't understand this UMF, why I'm putting UMF 0 plus plus, then you can have an extra condition. Let's say if prefix equals to K, so what I'm saying is that you can also have this prefix equals to K, then we just update our count, right? Update our count. So this would also work here. So you can do either of these two, right? So this is essentially making this is essentially equals to bringing 0 in our unordered map, right? So let me just run this and check whether it's working or not. So it's giving some error. So it's not, it's R, right? Expected this. So let me just run this code and then we'll check whether it's working or not. So okay, so this is our custom test case that I have explained you. So you can make K equals to 2 here, right? So we just have to see that the number of subarray in this particular array should be 5, right? So that's the case, and that what we got from here. So let me just submit this code and see whether it's working or not. So yes, it gets accepted. So even if you have any doubt in this problem, you just watch this video and try run by yourself. You'll be able to understand, right? So thank you, that's it for this video. If you like our content, make sure to subscribe this channel and don't forget to like this video. Thank you, have a nice day.